Watch this video about probability, the addition rule for probability, and the multiplication rule for probability. The first question states you have a box of 20 marbles, 8 of them are green, 7 are red, and 5 are blue. What is the probability that you will reach into the box and draw out a red marble? The probability of a red marble is 7 over 20. The next question asks what is the probability of selecting a green or a blue marble. For this problem, we will use the addition rule since it's an OR problem. The probability of a green marble or a blue marble is equal to the probability of a green plus the probability of a blue. The probability of selecting a green marble is 8 out of 20. The probability of selecting a blue one is 5 out of 20. When we add the two fractions together, we end up with 13 over 20. The next question asks for the probability that we select a black marble. This is an impossible event. The probability is 0. The next question says that a fair die is rolled twice. Find the probability of the following. Before we can answer the probability questions, we first need to write out the sample space. The sample space consists of the following outcomes: 1 1, 1 2, 1 3, 1 4, 1 5, 1 6, 2 1, 2 2, 2 3, 2 4, 2 5, 2 6, 3 1, 3 2, 3 3, 3 4, 3 5, 3 6, 4 1, 4 2, 4 3, 4 4, 4 5, 4 6, 5 1, 5 2, 5 3, 5 4, 5 5, 5 6, 6 1, 6 2, 6 3, 6 4, 6 5, 6 6. The first probability question asks us to find the probability that the first die is 2 or the sum is 6 or 7. Again, this is an OR problem. This time the events are not mutually exclusive, so we have to use the addition rule for events that are not mutually exclusive. The probability of a 2 or a sum of 6 or 7 is equal to the probability of rolling a 2 plus the probability of rolling a sum of 6 or 7 minus the probability that you roll a 2 and have a sum of 6 or 7. That equals 6 out of 36 plus 11 over 36 minus 2 over 36, which is 15 over 36, which will reduce to 5 over 12, or in decimal form, that's 417 thousandths. The third question asked us to find the probability the sum is 11 or the second die is 5. Again, the events are not mutually exclusive, so we'll use the same addition rule. The probability of rolling a sum of 11 or the second die is 5 is equal to the probability that you have a sum of 11 plus the probability that the second die is 5 minus the probability that you have a sum of 11 and the second die is 5. That is equal to 2 over 36 plus 6 over 36 minus 1 over 36, which is equal to 7 over 36 or 194 thousandths. This next question is also an OR problem, and the events are also not mutually exclusive. Again, we're using the same addition rule for events that are not mutually exclusive. The probability of someone being intoxicated or being involved in a driving accident is equal to the probability that the person is intoxicated plus the probability the individual is involved in a driving accident minus the probability of the individual being intoxicated and being involved in an accident. This is equal to 32 hundredths plus 9 hundredths minus 6 hundredths, which gives us a final answer of 35 hundredths. Moving on to this next question, the fourth question involves and with and, we use the multiplication rule. With this problem, we need to determine if the events are independent or dependent. In this case, they are independent. So we use the multiplication rule for independent events. So the probability of selecting someone who is stressed and someone else who is stressed and someone else is stressed is equal to the probability of someone being stressed times the probability of someone being stressed times the probability of someone being stressed. So that is equal to 46 hundredths times 46 hundredths times 46 hundredths. We could shorten that notation and just say that that is 46 hundredths to the third power, which is equal to 0.0973. The fifth question involves answering probability problems using a table. The first question asked us to determine the probability that a randomly selected U.S. resident 18 years old or older is male. This is just our basic definition of probability, successes over outcomes, which is 102.4 divided by 212.5, which will reduce to 1024 divided by 2125, which is 482 thousandths. The next part to this question is an OR problem, and again with OR we use the addition rule. We have to determine if the events are mutually exclusive or not mutually exclusive. In this case, they are mutually exclusive. That is, the two events cannot occur together. So the probability of selecting someone married or divorced is equal to the probability of selecting someone married plus the probability that someone is divorced. That equals 124.9 divided by 212.5 plus 21.7 divided by 212.5. That is equal to 146.6 divided by 212.5, which equals 1,466 divided by 2,125, which is equal to 69 hundredths. The next part to this question is also an OR question. This time, though, the events are not mutually exclusive. Since the events are not mutually exclusive, we say the probability of selecting a male or someone divorced is equal to the probability of a male plus the probability of someone divorced minus the probability of selecting a divorced male. This equals 102.4 divided by 212.5 plus 21.7 divided by 212.5 minus 9 divided by 212.5. That equals 115.1 divided by 212.5, which is 542 thousandths in decimal form. Question number 6 is an AND problem, and with AND we use the multiplication rule. Since we are using replacement, the events are independent, so the probability of drawing an ace, replacing that card, and then drawing another ace is equal to the probability of an ace times the probability of an ace. The probability of selecting an ace is 4 out of 52 times probability of drawing an ace again is also 4 out of 52. That will reduce to 1 over 13 times 1 over 13, which is 1 over 169. The last question is also an AND problem, and the events are independent. We're trying to find the probability of answering the first question correct, and the second correct, and the third correct, and the fourth correct. So that is equal to the probability of a correct answer times the probability of a correct answer times the probability of a correct answer times the probability of a correct answer. The probability of answering a question correctly is 1 out of 5. So we have 1/5 times 1/5 times 1/5 times 1/5. We can shorten that notation and say that that is 1/5 raised to the fourth power, which is 1 over 625.